Welcome to the second video of the chapter Carbon and its Compounds. In this video, we will discuss about the types of covalent bonding seen among covalent compounds and molecules. In the first video of this chapter, we understood that when a non-metal reacts with a non-metallic atom, instead of giving or taking electrons, electrons are shared among the atoms to form a bond, and such a bond is called as covalent bonding. In order to understand a detailed explanation of covalent bonding, please visit part 1 video from this channel. Let's now understand how a covalent bond is formed in the upcoming molecules and compounds. The simplest molecule formed through covalent bonding is that of hydrogen. The atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and it requires 1 more electron to fill the K shell so that it can attain the configuration of the nearest noble gas, helium. Through electron dot structure, we can show the bonding between hydrogen atoms to form hydrogen molecule. The valency of hydrogen is 1. Hence, we can depict this using dots or cross to represent the valence electron. In order to form a hydrogen molecule, there are 2 hydrogen atoms required. Each hydrogen atom shares 1 electron to the other one. The sharing is shown through circles which include the electron from the other atom also. Here you can see how hydrogen atom shares the electron among each other. The shared pair of electrons is said to constitute a single bond between the 2 hydrogen atoms. We can also represent a single bond just by drawing a line between the atoms. You can see on your screen how the single bond between hydrogen atom is shown. In the formation of hydrogen molecule, the atoms share 1 electron, or in totally we can say a single pair of electron is shared among the atoms. Let us recall that electrons are always shared equally and mutually. If one atom shares 1 electron to the other one, in turn it also receives 1 electron for sharing. Let's practice the formation of oxygen molecule. In order to form oxygen molecule, 2 oxygen atoms are required. Oxygen is the 8th element in the periodic table and hence its configuration is 2,6. Now the second shell, that is the L shell of oxygen, requires 2 more electrons to complete the octet. So each atom of oxygen shares 2 electrons with another atom of oxygen to give us the structure as shown here. The 2 electrons contributed by each oxygen atom give rise to 2 shared pairs of electrons. Hence, a double bond between the atoms is created. What would happen in the case of a diatomic molecule of nitrogen? Nitrogen has atomic number 7 and hence its configuration is 2,5. So nitrogen requires 3 more electrons to complete the L shell. Hence, when a nitrogen molecule is formed, each nitrogen contributes 3 electrons, giving rise to 3 shared pairs of electrons. This is said to constitute a triple bond between the 2 atoms. So from the 3 examples that we have seen, that is formation of hydrogen, oxygen and nitrogen molecule, we can understand that there are 3 types of covalent bond formed between atoms based on the number of shared electron pairs. Single covalent bond, double covalent bond and triple covalent bond. If 1 pair of electrons or 2 electrons are shared among the atoms, we call it as single covalent bond. When 2 pairs of electrons or 4 electrons are shared between the atom, it is known as a double covalent bond, and in a triple covalent bond, atoms share 3 pairs of electron or 6 electrons among each other. Carbon can also link with another carbon atom through single, double or triple covalent bond. Let's see the formation of 2 more covalent compounds in this video. Before moving forward in this video, take up a notebook and be ready with your pen, pencil and anything which you want. Also, don't forget to subscribe the channel and like this video. The first compound that we are going to practice today is formation of carbon dioxide. Carbon dioxide have 2 elements, carbon and oxygen, with configuration 2,4 and 2,6. So from the formula itself, we can understand that there is a single carbon and 2 oxygen atoms. In order to satisfy the octet rule, oxygen requires 2 electrons and carbon requires 4 electrons. So it is clear that carbon and oxygen shares 2 electrons each among each other. So keep carbon in the center and complete the electron dot structure of 3 atoms in the compound. Always understand, when we draw the electron dot structure, we need to represent only the valence electron. That is why we have represented 6 electrons around oxygen and 4 electrons around carbon. If you see the arrangement of electrons in carbon, it has been drawn conveniently so that while forming the bond or while drawing the bond formation, it will be easy to show. Now, carbon shares 2 electrons to one of the oxygen and 2 electrons to the other oxygen. So, if you see, oxygen atoms have completed their octet formation. Now, we have already learned that there is always equal and mutual sharing of electrons. So, if oxygen has received 2 electrons from carbon for sharing, then it will also give back 2 electrons to the carbon atom. So, you can see that we have drawn circles to represent this bonding. We can make sure that our drawing or our representation is correct by counting the number of electrons in each circle. In each circle, you can see there are 8 electrons, so that the atoms have completed their octet. Now let us represent the bond formation among these atoms. So carbon has shared 2 electrons and oxygen in turn has given 2 electrons to carbon. So there is 2 pairs of electrons shared among each atom. So you can represent that by drawing a double dash between the atoms, which represents a double bond. When we show the bonding between 2 atoms in a molecule or in a compound through short lines, such a representation is called as the structural formula of that compound. So the structural formula of carbon dioxide is O double bond C double bond O. The second example that we are going to learn is formation of water. Water is made up of the elements hydrogen and oxygen. Electronic configuration of hydrogen is 1 and oxygen is 2, 6. So here also from the formula we can understand that there are 2 hydrogen atoms and 1 oxygen atom. Now oxygen atom requires 2 electrons while hydrogen atom requires only 1 electron to complete the octet configuration. Hence let us place oxygen in the center and hydrogen on either sides of oxygen. You can see that there is a difference in the representation of electrons around oxygen from previous one. It is because oxygen here shares only 1 electron with hydrogen. So whenever you draw covalent compound, always show only the shared electrons or the number of electrons which are going to be shared among the or in between the space of the atoms. The rest of the electrons distributed around the atom in pairs. So here hydrogen requires only 1 electron and that is why we have shown the electron distribution around oxygen in this way. Now let's complete the octet of hydrogen. We know that hydrogen has only 1 shell, so it requires only 1 more electron. So first let's complete the octet rule for hydrogen, for both hydrogen. You can see that hydrogen has taken or oxygen has shared 1 electron with hydrogen. Similarly, oxygen has shared 1 more electron with hydrogen. So when electrons are shared equally and mutually, oxygen will also receive the 1 electron from hydrogen to complete its octet. Now let's try to draw the structural formula for water. Since each atom has shared only a single pair of electrons among each other, so we need to represent it through a single short line between the atoms. So this is how the structural formula for water looks like. The other case where we have shown with electrons is known as electron dot structure. You can also try the formation of chlorine, ammonia and carbon tetrachloride and check your results and check your understanding level. Always write the electronic configuration first and understand how many electrons are required by each atom. Also, try to place the atoms symmetrically. In the next video, I'll be uploading the formation of this chlorine, ammonia and carbon tetrachloride where you can check your results. So I hope that you have understood the 3 types of covalent bond and formation of carbon dioxide and water molecule. Thank you for watching the video. If you like the video, hit the like button and share the video among your friends and family. Also, show your support and love by subscribing the channel. While subscribing, don't forget to hit the bell icon so that you get notification instantaneously when the videos are uploaded. Stay healthy and stay safe, and I'll be back with another video of this chapter.